We start our lection by discipline interchangeability, standardization, and technical measurements. Theme 3. Interchangeability, tolerance and fits of smooth cylindrical joints. Unified system of tolerance and fits, ISO. The plan of our lecture. First item 3.1 size ranges, units of tolerances and international tolerance grades, ISO. 3.2 fundamental deviations, diagrams of the location of the fundamental deviations of the shaft and holes. And 3.3 hole system and shaft system, location scheme of tolerance fields for fits. And we start item 3.1, size, ranges, units of tolerance and international tolerance grades, ISO. The system of tolerance and fits is a set of regularity constructed series of tolerances and fits designed in the forms of standards. Currently, Ukraine has a system of tolerance and fits and the basic norms of interchangeability, which are based on ISO standards and recommendations. Unified system of tolerances and fits ISO extends to sizes up to 10,000 millimeters. ISO International Organization for Standardization. Dimensional accuracy is determined by tolerance. Different in size tolerances for size up to 500 millimeters are found by formula T is equal A multiplied by I, where I is the unit of tolerance, which expresses the dependence of the tolerance on the size in micrometers. I is equal 0.45 multiplied by root of the third degree of d suffix m plus 0.001 multiplied by d suffix m. In this formula, d suffix m is the geometric mean of the limit values of the interval of nominal dimensions. It is calculated by the formula d suffix m is equal square root of d minimum multiplied by d maximum, where d minimum and d maximum are the smallest and largest limit values of the interval of nominal dimensions in millimeters. A. So it was I. I is the unit of tolerance, and A, the number of units of tolerance. In these tables, you can see the numbers of units of tolerance. A, for the IT grade 0,1, A is equal 1. For example, IT grade 3, A is equal 3.7. And for example, for IT grade 14, A is equal 400. Within one IT grade, A is a constant. However, the tolerance in the same IT grade for different sizes change because with increasing size increases the unit of tolerance. In the transition of course precision IT grades, the tolerances increase due to increase in the number of tolerance units. In ISO for sizes up to 10,000 millimeters, 19 IT grades are established. In order of decreasing accuracy, IT grades tolerances are conditionally indicated IT 01, IT 0, etc., and IT 17. International tolerance grades, it's IT grades. IT, it's international tolerance grades. So you can see the line of these IT grades from IT 01, IT 0, IT 1, IT 2, and to IT 17. These are the standard tolerance grades. These tolerance values will be calculated with the help of the relevant magnitude given below. IT grade 01 to IT grade 4 for the production of gauges, plug gauges, measuring instruments. From IT grade 5 to IT grade 7 for fits in precision engineering applications. From IT grade 8 to IT grade 11 for general engineering. From IT grade 12 to IT grade 14 for sheet metal working of press working. And from IT grade 15 to IT grade 16 for processes like casting, general cutting work. There is a table, fundamental tolerances for grades IT 01 to from IT 01 to IT 16. For example, calculate the standard tolerance value. Question: calculate the value of standard tolerance IT grade 7 of diameter 100 millimeters of the shaft. Answer: step 1, calculate the geometrical mean. D. The shaft diameter 100 lies in the nominal size range from 8 to 120 millimeters. And the geometric means D is equal square root of 80 multiplied by 120. And it's equal 98 millimeters. Step 2, calculate standard tolerance factor. We use the formula 0.45 root of the third degree of D, and D is equal 98, plus 0.001 multiplied by D, and D is equal 98. And we have it's equal 2.172 micrometers. And step 3, calculate the value of tolerance IT7. For IT7, A is equal 16. Let's look our table in previous slides. IT grade 7. IT grade 7. IT grade 7. Here you are. and A is equal 16. So IT grade 7 is equal 16 multiplied by I, and we have 16 multiplied by 2.172, and we have 35 micrometers. It's IT grade 7 for value of standard tolerance IT7 for diameter 100 millimeter of the shaft. And now we start item of our lecture 3.2, fundamentals deviations, diagrams of the location of the fundamental deviations of the shaft and holes. A number of tolerances of 19 IT grades and 28 fundamental deviations of the tolerance fields of shaft and holes have been established for the formation of tolerance fields for each interval of nominal dimensions. The fundamental deviations are denoted by 1 or 2 letters of the Latin alphabet. You can see it's A, B, C, C, D, D, E, F, F, G. For hole, we use big letters, and for shaft, we use small letters. Fundamental deviation letters for holes, basis H, and fundamental deviation letters for shafts, small h. We use small letters. Fundamental deviations. The fundamental deviation is that limit deviation which defines that limit of size which is nearest to the nominal size. Nominal size corresponds to the zero line. The fundamental deviations are identified and controlled by upper case letters for holes from A to ZC. Holes deviations A, B, C, D, you can see the letters. All letters are big. Lower case letters for shafts. Lower case letters for shafts from A to ZC. Shafts A, B, C, D, but letters are small. And you can see on this scheme the tolerance fields and its fundamental deviations for the shaft and for the hole. The fundamental deviations of the holes should allow the formation of fits in the hole system and in the shaft system with equal clearances and interferences. To do this, there are two rules for calculating the deviations of the holes, general and special. According to the general rule, the fundamental deviations of the holes are taken equal in absolute value and opposite in sign to the fundamental deviations of the shafts, denoted by the same letters for holes with the fundamental deviations from A to H. Big E is equal minus small es. For holes with the fundamental deviations from I to ZC, big ES is equal minus small e. In exception to this rule is made for deviations of holes larger than 3 millimeters, J, K, M, and N, with tolerance to IT grade 8, inclusive in deviations from P to ZC to IT grade 7 inclusive, A special rule has been established for them, and big ES is equal minus small e plus delta, where delta is equal IT grade suffix n minus IT grade suffix n minus 1. The difference between the tolerance of the considered IT grades and the tolerance of the nearest accurate IT grades. And rules for fundamental deviations for holes. You can see general rule and special rule. Fits of all three groups. Now we start next item of our lecture. Hole system and shaft system. Location scheme of tolerance fields for fits. Fits of all three groups with different clearances and interferences can be obtained by changing the position of the tolerance fields of the two paths being connected. However, it is more convenient in technological and operational terms to obtain a variety of fits by changing the position of the tolerance field of only the shaft or only the hole. The path in which the tolerance field is not allowed to fall due to type of fit is called the main part of the system. In ISO, the main parts are holes of shafts with a fundamental deviation of 0. Types of fit. There are two basic systems for given tolerance: the hole-based system and the shaft-based system. The main part is the part whose tolerance field is the basis for the formation of fits. Fits in the hole system are fits in which clearances and interferences are formed by changing the limiting dimensions of the shaft. You can see it in figure 3.2. A. Fits in the shaft system are fits is which the necessary clearances and interferences are formed by changing the limiting dimensions of the hole. You can see it in figure 3.2b. The hole-based system. Hole basis, lower deviation is 0 and fundamental deviation is big H. And you can see first variant of the shaft, second variant of the shaft, and third variant of the shaft. You can see there are clearance in the fit. There are clearance is equal 0. And there are interference in the fit. The shaft-based system. Shaft basis upper deviation is 0 and fundamental deviation is small h. Base size of shaft, and you can see three types of fits. Fits with the clearance, transition fit, and fit with interference. Limit deviations are assigned to all dimensions indicated on the working drawings. The accuracy of smooth elements for which deviations are specified by a common record is normalized either by IT grades from IT 12 to IT 17 for sizes from 1 to 10,000 millimeters, or by accuracy classes, accurate, medium, rogue, and very rogue, denoted by the letter small t. Accuracy classes are conditionally named and denoted: accurate T1, medium T2, rogue T3, and very rogue T4. In the listed accuracy classes, the limit deviations are set for the enlarged intervals from 6 to 30, from 30 to 120, and obtained by rogue rounding of the average tolerance calculated according to the tolerance adopted respectively in IT grades 12, 14, 16, and 17 for the size intervals included in this enlarged interval. For the sizes of the metal details processed by cutting, IT grade 14 and accuracy class T2 are preferred. There you can see maximum hole size, basic size, upper deviations of the shaft and of the hole. And in figure 3.3, you can see designation of limit deviations and fits in the drawings. 3 types of designation of limit deviations and fits. First type with fundamental deviation, IT grade, and upper limit deviation and lower limit deviation. Second type, only nominal diameter and upper limit deviation and lower limit deviation of the shaft. And third variant, only nominal diameter and only fundamental deviation and IT grades. The same types for the whole too. The same designation of limit deviation and fits in the drawings. Okay, our lecture is finished. Thank you very much. Goodbye. See you next time.